Welcome everyone. If you are watching this video, that means we have finished from our lab 1 to lab 4 for our Introduction to Fluid Mechanics lab ENGR 3404. Today we're gonna talk about the lab 5, which is flow rate measurement using a Pitot tube. The learning objective for this lab is that how to measure the dynamic head produced by water flowing inside a pipe using a Pitot tube. And we'll also learn how the dynamic head of a fluid flowing inside a pipe varies with radius due to the development of a boundary layer at the wall of the pipe. So the theory for this lab is very simple. The total pressure is the summation of a static pressure and the dynamic pressure. If we see the Pitot tube here, this direction, the flow is flowing with a velocity of v, and this is our Pitot tube. At the tip of the Pitot tube, there is one opening, and there is opening on the sides of the Pitot tube. Now, at this point, there is the total pressure acting, which is the summation of the static pressure and the dynamic pressure. Now, for the hole on the sides, there is no dynamic pressure because it's across the direction of the flow. So there is only the static pressure working at this point. So if we measure the pressure at this point and that point and the difference, we can get the dynamic pressure, because this will give us the total and this pressure on the side will give us the static. So the difference would be the dynamic pressure. Now, we also need to understand and use the Bernoulli equation, the famous Bernoulli equation that we already know. The Bernoulli used in equation the concept that there is three forms of pressure or energy in a volume of fluid that is flowing, and the fluid is inviscid, meaning it has no or negligible viscosity. So these three forms of pressure in a fluid are the static pressure, the dynamic pressure, and the elevation pressure. All these three consist the total pressure. Now we can replace the dynamic pressure in terms of velocity as rho v square over 2. And if we assume the pipe is not moving its elevation, we take the pipe as our datum, then z would be 0. So this cancel out. Now we have only this three term. Now if we solve for the v, we call it v theoretical because we are just deriving it from the equation. So theoretical. So if we take the PS, the static pressure on the other side, PT minus PS, 2 goes up, rho goes down, and then square root. Now if we again replace PT minus PS in terms of pressure head, we can write rho GH, that the formula we already know, del H, right? So if we put that and rho cancel out, we just left with 2GH. And that is our equation that we're going to use for theoretical velocity measurement. How do I find the experimental velocity, flow velocity? Well, if we can measure the volume that is passed over a certain period of time through the pipe, and if we know the cross section, we can know the velocity of the fluid. And this, the theoretical and experimental, we're going to compare in this test. Next, let's see the two type of tests we're going to do today. First, we're going to use the Pitot tube. We'll measure the pressure head and the fluid velocity. So we'll collect one set of data for this, and we'll just change the position of the Pitot tube, and those arrangement will give us the dynamic head profile inside a pipe. So we know that when the fluid flows, there is a boundary layer towards the pipe. The flow is 0, flow velocity, and the velocity is maximum in the center. So there is a profile, and we'll take the data and we'll develop the profile for our setup. So next, Let's talk about our equipment that we're going to use for this test. So let us introduce ourselves with our system. We have our pump here. The top switch is the switch for pump, and this knob regulates the flow, and this indicator will show how much liter I have stored in the tank after the flow. I'll show you. On top we have connected the tube, the pump inlet, the pump outlet, so the water will come in, go to here, and it will go all the way through. And we put the Pitot tube way far from the inlet so the stream may stabilize and we can get better result. On the other hand, we have a valve that is fully open. We can close this valve to see only static pressure, and this is the reservoir I was talking about. If we close the O-ring down there using this placing right there, then I'll be storing the water that is coming through the system, and I can measure the volume and divide it by the time and get the flow rate to compare with the Pitot tube value. Now, coming back to our Pitot tube, if you see inside, we have the Pitot tube here, and I have notches here at different position. If I put the notch at the fourth notch, 1, 2, 3, and then now it's the fourth, then the Pitot tube should be centered in the pipe. The Pitot tube, how it works, you already know, is that it has an opening at the point and then opening on the sides. So at the face point, you have the summation of the static pressure, which is same for every position in the liquid or water and the wall, plus the dynamic pressure. But on the side of the Pitot tube, there is only static pressure. So what it does here, you see the Pitot tube, it is separated into two ends. One is going straight, that is the summation of static and dynamic, and this is the side, it will be only the static pressure. So these two tubes come and that is hooked into our digital manometer, and I want to show you how I connected. There is P1 and P2 for differential input. For P1, I added the total pressure, that is the summation of static and dynamic,
and P2 is only the dynamic pressure line I connected, and that way I'll get a positive pressure head. If I switch it, I'll get negative pressure. So I have to follow that step. And for the unit, I put meter H2O, so it's water scale. I have to, before I start, I have to do make it 0, and it will be balanced at that position before I start our test.
So now we have introduced ourselves with our equipment. Now we're going to take the data for our first part of this test. At targeting some pressure head 0.2 to 0.1, we'll target to be accurate at this head, but our reading could be a little bit different, 0.19, 2.1. We will record the actual pressure head that we receive and the time it takes to get 40 liter.
So now we will collect the data for our test. We have two steps, two parts of this lab. For the first part, where we'll be using a Pitot static tube to measure the dynamic head and fluid velocity. So for that, I have set the Pitot tube in the center at notch number 4, and I have connected my manometer. Now I'm going to turn on the pump. There is no flow. I have to turn on the knob. You see the pressure head going up high. We have to set it up for the prefixed del H, which is 0.2, 0.4, and so on. So our target is to have 0.2 meter here, and then we can measure the time it takes to fill up the 40 liter. So I'm going to increase the flow rate. It's too much, so slow down. So our dynamic pressure head is about 0.2. That is our target. So now it is stable. I'm gonna start use our stopwatch and start measuring the water level, how much the time takes to reach the 40 liter. So I have locked the orifice. The water level is going high. I started at 0. It's going up, and I'm measuring the time. The time it takes for this one to reach 40 liter. That means there is 40 liter of water stored in this reservoir, and that way I can measure the flow rate to compare with the Pitot tube. So it's about 32 seconds. So this is the reservoir where we're storing the water. If I lock the orifice, see, if I go over the 40 liter, we don't have to worry because there is a safety opening. So if the tank is full to 40 liter, the additional water will go from this opening. So what I'm gonna do is that open the O-ring, so the water will go down now. So the tank is being emptied. Once all the water goes out of this tank, we can start the second data taking. So now we will repeat the data taking. We will change the dynamic pressure head from 0.2 to 0.4, 0.6, 0.8, and 1. So there will be 5 data points, and we'll repeat the same process. I will rotate the knob to increase the water flow. You see it's about 0.4. I have to maybe adjust a little bit, and then I can take another data point at 0.4, and then I'm going to take data point at 0.6, 0.8, and 1. And for each test, we're going to measure how much time it takes to fill up the 40-liter tank we have here.
So we have finished our first part of the lab. For the second part of this lab, to determine the dynamic head profile in the pipe, we will change the position of the Pitot tube head inside the tube, and we call the position from 1 to 7. The distance of the Pitot tube head or the tip from the top wall, for each position it is changed by 3 millimeter, and for all the changes we will get the distance 3, 6, 9 up to 21, and for all those positions you have to measure the head.
So by doing this test, we will change the position of the Pitot tube inside the pipe, and we will keep the flow rate fixed. Unlike the previous part, for this part we'll keep the flow rate fixed at a position, but over time we'll change the location of the Pitot tube, and that's how we're going to measure what is the dynamic pressure at different position of the Pitot tube, and from there we'll develop the dynamic head profile. So I'll show you how to do it. You see there is notches here. I have to open from here to unscrew the Pitot tube with the system, from the system. It's open, and now this is also unlocked. So see, I can go up and down. That will change the position of the Pitot tube head inside the pipe. So I will start with the top. At this position, the Pitot tube is 3 millimeter from the top wall. So now I have to again fix this one. I have to lock this one so that it's fixed. At this position, the Pitot tube is only 3 millimeter down from the top. I can use this part to rotate the head inside the pipe, because even you are at the top head, the head could be angled other than straight or this way. So what I have to do is that use this one to see if it's facing straight forward to the streamline. So again, we'll keep the flow rate fixed, and we'll change the position of the Pitot tube from top to the bottom, having the Pitot tube at all the notches we have, and we'll take the pressure head difference, dynamic pressure head, and we'll see the profile for dynamic head from top wall to the down wall, and it will be maximum at the center with this test. Thank you.
So we have collected all the data. Now you have to do your calculation using the equation that we showed you at the beginning. Find your dynamic head, taking the difference from your Pitot tube data, and you calculate the flow rate. Now you plot dynamic head with your flow rate, and you will get one plot. You also calculate the experimental velocity and theoretical velocity using the equation that we showed you, and plot them with each other, and it will show you how one is different than another. For accurate case, a value of 2 experimental should merge with 2 theoretical. If they're off, then what it means is that they are not accurate, and you can measure the difference and their trend of difference. And this is the second part of the test, where you should see similar profile. If we could have taken more data points, the more data point you take, the more uniform curve you will get. So if you plot the distance from the top wall and the theoretical velocity from your data, you should get similar plot. Finally, in your discussion, you should add a comment on the shape of the graph you receive or you get from the volumetric versus the dynamic head curve. Comment on the possible reason for if you see any difference in the plot, the velocity, experimental and theoretical velocity plot in the two methods. First one for the velocity and the second one was the velocity dynamic head profile. So if there's a difference, if you see, comment on that. Also comment on the shape of the velocity profile. It should be almost like a D shape, right? And comment why it's like this, why not, those kind of stuff. So that was the part of our lab 5. Once you finish your lab, so upload the report. For lab 6, we'll do curvilinear flow, the P set. You should prepare yourself with the lab handout and reading textbook, and also you'll find the video in the channel. Until then, see you again. Thank you.